Assalamualaikum warahmatullahi wabarakatuh. Hello guys, my name is Vidya Erningsi. I'm from Physics B. I will explain about the map of the physics. This is my attempt in the show that in a map. This is the map of the physics. I hope you enjoy it.
Physics can be broadly broken down into classical physics, quantum physics, and relativity. We'll start with classical physics, and a good person to start with is Isaac Newton. His law of motion describes how everything made of matter moves above, and his law of universal gravitation tied together the motion of planets in the sky with the falling of objects on Earth into one elegant and general description. He also invented calculus, a supremely powerful mathematical tool which has been used over decades to reach to derive new physics. Calculus is really part of mathematics, but physics and mathematics are inseparable. Math is the language of physics. You can imagine it like the bedrock that the world of physics is built from. Newton also made studies in the field of optics, which is the physics of light and how it travels through different materials. Example reflections in prisma and lens which are used to focus light in the telescope, microscope, and camera. Telescope enable us to peer into the depth of space of observe the width of objects there and develop astrophysics and cosmology. Optics is closely related to the theory of wave, which is basically how energy can travel through the true band of a medium, like ripples on the surface of a pond of sound through the air. Light doesn't need a medium to travel through. It can travel through the vacuum of space, but it still follows the same principle as all wave, namely reflection, refraction, and diffraction. This led us to electromagnetism, the description of magnetic electricity, or more generally electric and magnetic field. It was a physicist called James Clerk Maxwell who discovered that there are two aspects of the something and derived the wonderfully elegant rule of electromagnetism. Theory that the light was an electromagnetic wave. Electromagnetism also explains a lot of electricity. Jumping back a little bit, classical mechanics are related to Newton's laws and cover the property and motion of solid objects, how they move when force hit them, what happens when they are joined together, like in gear of building of beer gas. Fluid mechanics is the description of the flow of liquid and gas. Using fluid mechanics, you can work out how much lift is generated from aeroplane wings or how aerodynamic a car is. Fluid mechanics is notoriously difficult, mostly because motion of tiny things like molecules get really complicated really fast, which led us to chaos theory. Chaos theory is the description of large complex systems and how small difference in initial conditions can lead to very different final outcomes. Thermodynamics is the description of energy and how it passes from one form to another. It also includes entropy, which is a measure of order and disorder, and basically tells you how usable different kinds of energy are. Energy is fundamental property to physics, and also I have written energy here. I should have written it everywhere on this map because everything has energy. So this is all of classical physics, the picture of the universe we had around the year 1900. It told us we live is the universe where everything runs sort of like clockwork. If you could measure everything accurately enough, the future was kind of predetermined. However, not everything was solved. There were just a few of the whole in experiment that hinted at something more. The orbit of Mercury was likely too fast, and some strange things happening on the smallest sky with electrons and light waves are unique planet. Physics at the time it thought that they would solve and explain this problem so enough, but poking at the time universe did not domain in relativity and quantum physics, and turning our understanding of the universe completely on its head. Albert Einstein was the genius of developing the theory of special and general relativity. Special relativity predicts that the speed of light is the constant of all observed, which means that when you travel really fast, well, stuff starts happening like time slowing down. It also states that energy and matter and different aspects of the same thing through the formal formula E mc². General relativity says that space and time are part of the same fabric called spacetime, and that the force of gravity comes from objects bending spacetime, making other objects fall in toward time. While relativity describes the very big physics were busy at work on the first mile in the world of quantum physics. Atomic theory probed the nature of the atom, and more detailed descriptions of the atom were developed. From a thin sphere to electron orbit to energy level and then to electron beam wave like chain distribution. Condensed matter physics describes the quantum physics of many atoms together in solid and liquid, and is where many great technology have come from, like computer, laser, and quantum information. Nuclear physics describes how the nucleus of atoms behave and explains radiation, nuclear fission, the splitting of the atom used in our nuclear power plant, and nuclear fusion which takes place in the sun, and we have shown the harness here on Earth. Particle physics probing even deeper to find the fundamental subatomic particle that everything is made of and are described in the standard model of particle physics. Quantum field theory chapter of quantum physics and combines it with the special theory of relativity and is the best description of the universe we have. Unfortunately, quantum field theory doesn't include gravity, and so physicists don't know how to join together quantum physics and the general theory of relativity, leading to the camp of ignorance. One day in the future, we hope to close this camp and to come up with the theory of physics. We call it quantum gravity, and there are many attempts to do this. Some explain a string theory and loop quantum gravity, and there is many more. But quantum gravity is not only thing we observe but don't understand. There are also the major puzzle of dark energy and dark matter which seem to make use 95% of the universe. So all of our physics only really describe 5% of what we know about and everything else, and the moment is a mystery. There are many other mysteries out there like the Big Bang and no other thing beyond that we don't even know that we don't know, which gets lovely cloud with flood overall of physics. Philosophy. Also many physics make fun of philosophy. It is the big philosophical question that motivates a lot of physics, like what is the fundamental nature of relativity? How come the universe even exists? Do we have free will if we are just made of physics? Of how do we know that we do physics and science actually get to the fundamental truth of the universe, and just why is all of physics like the way it is? Well, those are the big questions, ones which we may or may never answer, but that is no reason to give up trying. After all, physics are not quitter, and that was the map of physics.
So that's the end. Thanks for watching this video, and I hope you enjoyed. And if you want me to do more, like, comment, and subscribe. And see you. Bye bye. Assalamualaikum warahmatullahi wabarakatuh.